Hello, viewers, and welcome to today's edition of Classroom Lectures. And with me, your teacher or lecturer, Fauzan Harun. Welcome to the channel once again, the channel of choice. Please do also subscribe to the channel for me. Today, we are going to look at the chemistry lesson. We are starting with chemistry lesson. Chemistry class. Chemistry class. Today we are starting with chemistry class. And topic is amount of substance. Amount of substance and amount of substance and the mole. Amount of substance and the mole is the topic for discussion. Amount of substance and the mole. That's the topic for discussion today. And then there are so many topics in the syllabus for the junior high school across the world, and this is one most important topic, and for that matter, it is one of the basics of chemistry that we need to know in terms of the chemistry course. And first of all, we are taking an aspect, relative atomic mass. Relative atomic mass. We are going to look at relative atomic mass. And when we say relative atomic mass, what does it mean? When we say relative atomic mass, what does it mean? In simple terms, when we say relative atomic mass, it is defined as the average mass of one atom of an element compared with 1/12 of the mass of one atom of carbon-12. So its symbol is represented by relative atomic mass is represented by AR, and AR is equals to the mass of an element compared to 1/12 the mass of one atom of carbon-12. So this is what we mean by relative atomic mass. This is what we mean by relative atomic mass. The mass of an element compared with one atom, mass of one atom, the average mass of an element, the average mass of an element, the average mass of an element compared with 1/12 of the mass of one atom of carbon-12. So this is relative atomic mass. This is what we mean by relative atomic mass. Relative atomic mass is a pure number and has no units. Pure number and has no units. It's a pure number and has no units. AR is pure number and has no units. It has no units. It's a pure number and has no units. And I think in the next page, I'm going to prove to you why it has no units. I'm going to prove to you why it has no units. I will prove to you why it has no units. So I'm going to do the proof by cleaning the top there. I'm going to do the proof by cleaning the top there. So let's rub this and I will do the proof. Let's rub this and I will do the proof. If you are missing some points, please do what to reverse or repeat the video to understand effectively. That's why I'm taking time to record for you, so that you make sure you account for wherever you fall short. We are going to look at why it has no units. Why it has no units. And then, so if AR, relative atomic mass, is equals to average mass of an element in the mass is in grams, which is G, divided as compared to 1/12 the mass of one atom of carbon 12, also in grams. Those of you who don't know this, those familiar in chemistry know it. The 12 superscript and then the subscript at the left side of the carbon is the carbon 6, the atomic number 6, and then the mass number is 12. So the reason why it has no unit is that you can see from this equation that G will cancel G, gram will take out grams. And then if gram takes out gram, then whatever value you get here has no units. Those mathematicians and chemistry students understand what I mean. It has no units. So this is relative atomic mass, the basics. It has no unit. So let's also, it has no units. Let's proceed to the next aspect. Let's proceed to the next aspect. We have the atomic mass unit. The atomic mass unit is 1/12 of the mass of one atom of carbon-12, represented by mu. Represented by mu. Atomic mass unit is represented by mu. A mu. That's the symbol mostly associated with it in chemistry. Represented by mu. That's the symbol associated with it in chemistry. Represented by mu. On the carbon-12 scale, one atom of carbon-12 isotope is therefore taken to have 12 units of atomic mass. So on the carbon-12 scale, one atom of carbon-12 has 12 units of atomic mass unit. So atomic mass unit, mu, atomic mass unit, AMU. Atomic mass unit of carbon is equals to 12 mu. 12 mu, because carbon has a mass of 12 grams. So its atomic mass unit is 12 mu. Remember, relative atomic mass has no unit. So its relative atomic mass will be what? AR of carbon will be what? 12. Because the reason why it is 12 is that you have carbon, average mass of carbon to be 12 over 12 grams over 112 times 1 atom of carbon, which is also 12. So this takes this takes this 112, sorry, and this 12 cancel 12, so we have 12. Hence 12 is the relative atomic mass, while the atomic mass unit is mu, 12 mu. So I hope we are getting the point so far. So the difference between relative atomic mass and atomic mass unit is the unit mu. The atomic mass unit, you attach mu. The relative atomic mass unit is no unit. Of course, if we say something is relative, it means we are comparing one thing to the other, meaning we have the numerator divided by the denominator. Hence, the units will delete or cancel each other. So that is what we are talking about. In the same way, let me delete and continue. If you missed some points, please repeat the video. When on Fauzan Harun channel, first chemistry lesson, repeat the video if you miss anything, please. That's why I'm recording every detail for you. That's why I'm recording every detail for you. So the atomic mass unit for magnesium. Atomic mass unit for magnesium. Magnesium element, magnesium, AMU, Mg is the symbol, is equals to what? 24 mu. 24 mu. But the relative atomic mass will be what? Your guess is as good as mine. It will be atomic relative mass of magnesium is obviously 12. So this is what we are talking about. I hope I've made sense with respect to this video. Please do subscribe to the channel, especially the students, chemistry students from junior high school across the world. So today I will end the lesson by giving you one assignment to calculate those. So those assignment, answer the assignment in the comment section. The assignment should be answered in the comment section. In the comment section. The assignment calculates the relative atomic mass and atomic mass unit of the following elements: I, sodium, aluminium. So this is the assignment for the viewers, which should be done in the comment section. Do well to ask any question if you don't understand anything. And I would like to bring my first lesson to a successful end. Thank you very much for joining me on the channel. Please do subscribe to the channel. More topics will be uploaded. The next section will focus, then my next chemistry lesson will be on the relative molecular mass. Relative molecular mass, that's the next topic. So do well to learn and send in your questions. Give it a thumbs up if you understand the lesson for today. Thanks for joining me. God richly bless you. Cheers. Bye bye.